All right, this is going to be the Unit 6 test review, and we're going to start with some graphs here. So for 1A, we're looking for the asymptote, and what that is going to be is where this graph here is going to level off. So if you look, you can see it levels off at this line right here. So that purple line I've drawn, that is where this starts to become a flat line, and that's going to be our asymptote. Now the asymptote is always going to be an equation that's y equals some number, and all we have to do is look at what y value this line where it levels off is. So look, it's 1, 2. So y equals 2 would be the equation of our asymptote. Now the y-intercept is where it's going to touch the y-axis, which would be this point right here at 3. And we know we always mark the y-intercept as a point, so the x is 0 and the y is 3. For domain, this is our x values, and notice these arrows go to the left forever and also to the right forever. So our domain for exponential functions is always going to be all real numbers. And then the range is not all real numbers, just because if we notice, the asymptote tells us which y values it's not going to hit. So our exponential function is never going to touch that asymptote, but it's going to get really, really close to it. Since ranges are y values, we're going to put a y there. And then we're going to use the number that we have from the asymptote, so it's going to be a 2 in this case. And then we just have to see, is this above the asymptote or is it below the asymptote? Since our graph here is above our asymptote, it's going to be y is greater than 2. And make sure you don't put the equal to sign here because this graph will never actually touch the asymptote. So y is never equal to 2. All right, same thing on the other side. The asymptote is where it levels off. So if we look, right here would be our asymptote, and that would be at y equals 4. Our y-intercept is where it hits the y-axis, which would be right there at 3, so 0, 3. Again, domain is always all real numbers. Just going to go ahead and write that in. And then the range, we need to use our asymptote again, but it's going to be a y. Our asymptote has a 4, so I'm going to put a 4. But this time our graph is underneath the asymptote, so it's going to be less than. So y is less than 4. And again, we don't put that equal to line. We're just going to leave it as greater than or less than. Okay, for number 2, this is going to be an exponential growth or decay problem. So you've been working on these in class this week. And the number of mosquitoes at the beginning of the summer was 4,000. The population is expected to grow at a rate of 25% a month. How many mosquitoes will it be after 4 months? So this word right here, grow, that tells us this is going to be a growth problem. So we just need to write our equation. So it'll be y equals, and remember, the a value is the number outside of the parentheses, and that is always our initial amount or the y-intercept. So if we read this problem, it says there were 4,000 mosquitoes to start. So that's going to be the number that goes outside of the parentheses. And since this is a percent problem, remember we need to put a 1 there. And since it's growth, it's going to be 1 plus. Now we need to change this 25% into a decimal, which would be 0.25. Then it's going to be to the power of t. So I know we've done x sometimes as our exponent, but here we're talking about time, so we're just going to put a t there. It's really the same thing as an x. So that's our basic equation, but this question is asking for how many mosquitoes there will be after 4 months. So we're going to replace that t with a 4. So we get y equals 4,000. I'm going to go ahead and add the 1 and the 0.25. So 1 plus 0.25 is just 1.25. And then our time here is just going to be 4 months, so I'm going to put a 4 as my exponent. Now, you're either using a yellow calculator at school or Desmos at home, and I'm just going to show you Desmos, but if you're using the yellow calculators, it's pretty much the same exact thing. So for Desmos, all we're going to do is we're just going to type that in. So it's going to be 4,000. You don't need the y equals. Then 1.25. Then we use the exponent to the power of 4. And there we have our answer. It's going to be 9,765 mosquitoes. And that's our answer. Okay, for 2B, we've inherited land and it was purchased for $30,000 in 1960. The value of the land increased by approximately 5% per year. What is the approximate value of the land in the year 2011? Okay, so I'm going to have y equals again. And outside of the parentheses, we need our initial amount. So if we look, we can see it was purchased for $30,000. And since it says increase, this is going to be another growth problem. So we're going to have 1 plus. But then I have to write 5% as a decimal, which would be 0.05. Make sure you don't write 0.5 because that would be 50%. And then to the power of t. Now this time it doesn't really give us what our time is. We're going to have to find it. But all I have to do is subtract these 2 years they give me to find the change in time. So it would be 2011 minus 1960. So that would be 51 years have passed. That's going to be my time. So y equals 30,000. I'm going to go ahead and add that and get 1.05 to the power of 51. And then back to Desmos. To type it in, and there it gives us our answer. It's going to be 361,223. And this is going to be multiple choice, so just find the answer that is closest. Yes, I did just round off to the nearest dollar, but it may have some cents there. Okay, for 3A, we need to write an equation based on the table. Now, this is not going to be a growth or decay problem. This is just going to be a normal y equals a times b to the x problem. So the two things we need to find are a, which is our y-intercept, and b, which is our growth or decay rate. Okay. Oops. Okay, so a, that's going to be our y-intercept, and we know that the y-intercept happens when x equals 0. So when x equals 0, y equals 5, and that means a is 5. Now to find b, I need to see how much we're multiplying to get from one to the next on all of these. So to get from 5 to 10, that's going to be times 2. 10 to 20 is times 2. 20 to 40 is times 2. So our b value here would just be 2. Now we just have to write our equation from this, so it becomes y equals 5, then in parentheses, 2 to the power of x. All right, the next one we're going to do the same thing. So I just need to find A and B. A is going to be your initial value or your y-intercept. When x equals 0, y equals 729. So A is just 729. And then B, we need to see how much is changing for each of these. So from 729 to 243, that's going to be dividing by 9. So that's really times 1/9. 243 to 81, it's going to be the same thing. So times 1/9. And 81 to 9, same thing, times 1/9. So our B value here is just going to be 1/9. And that means our equation is y equals 729 1/9 to the power of x. And that one would be decay instead of growth. All right, moving on to 4. So Melanie bought a used car, and it was for $18,000. The car dealer said the value of the car would decrease 12% for the first year, and it would continue to depreciate in value by 12% each year. How much would the car be worth in 6 years? So this one, it says decrease and depreciate. Both of those tell us it's going to be decay. So first off, we need our initial amount, and this car is going to be starting at $18,000, so that is our initial amount. Then in parentheses, we have a percent, so we're going to do 1. And since it's decay, it's going to be minus this time. 12% as a decimal is 0.12, and that's going to all be to the power of t. So in growth and decay, t is the variable we use more than x. So our equation here would be y equals 18,000. 1 minus 0.12, you can do that in the calculator. You would get 0.88 to the power of t. And then here, our t, it's saying after 6 years, so I'm actually going to change this t to be a 6. And then that's what I'm going to type in to Desmos. So I get 8,359. Dollars. So after 6 years, that's how much this car is going to be worth. Okay, 4B, it says the value of an antique piece of furniture is currently $1,500, and it's increasing at a rate of 6% each year. How much is it worth after 4 years? So I'm going to have y equals, notice we need A, which is our initial amount, and this one says it starts at $1,500. So that's going to be what's outside of the parentheses. We have a percent again, so we need that 1. And it's increasing, so that would be 1 plus. And we write 6% as a decimal, it becomes 0.06 to the power of t. So if it's a single digit number, make sure you put that 0 in front, not just 0.6. So then I have y equals 1,500. If I add that, I get 1.06. And then it's looking for after 4 years, so that t is going to become a 4. Then I can just use my calculator. And I get 1,893. Did I write that wrong? I think I did. Oops, yeah, I mixed up the 8 and 9. Sorry, that should actually be 1,893. And a good idea on these is to look at your answer choices and make sure it makes sense. So like this one, we knew it should have increased, and 1,800 is more than 1,500, so that makes sense. And then this car was 18,000, now it's 8,000, that makes sense as well. All right, on to number 5. So for A, an adult takes 600 milligrams of ibuprofen. Each hour, the amount decreases by 19%. How much ibuprofen is left after 6 hours? So let's look at this one. It's going to be another growth or decay problem. So I have y equals. The first thing we need to find is our initial amount. So that's going to be the 600 that they started with. Whatever the initial amount is goes outside of the parentheses. Then it's a percent, so I'm going to have a 1. And it's decreasing, so I'm going to be subtracting. 19% as a decimal is 0.19. It's going to be to the power of t. And then we're looking for after 6 hours, so I'm going to rewrite this as y equals 600. 1 minus 0.19. If you put that in the calculator, you're going to get 0.81 to the power of t. And we're looking for 6 hours, so I'm going to change that t to a 6. So then I type it in, 600.81 to the power of 6. And you get 169.45. Okay, 5B says you drink a beverage with 120 milligrams of caffeine. Each hour, the caffeine in your system decreases by 12%. How much is left after 5 hours? So another decreases, that's going to be decay. And we have y equals, the initial amount is going to be this 120 milligrams, so 120. It's percent, so I have a 1. And since it's decay, it's going to be minus. 12% as a decimal is 0.12. It's going to be to the power of t. Then I simplify this, so y equals 120. 1 minus 0.12. If you're not very comfortable subtracting decimals like this, just put it into the calculator as 1 minus 0.12. That's okay. But you would get 0.88. And then we're looking for after 5 hours, that t is going to become a 5. Okay, so we have 120 point, what was it? 88 to the power of 5. So it should be 63.32. Oops. There we go. And that would be our answer. So that's how much milligrams of caffeine is left after 5 hours. Okay, 6A, we're trying to see, filling in this information for the equation given to us. The first thing it's asking us is it growth or is it decay? So that's when we need to look at the B value here. So the growth or decay factor is going to be 0.5. And we learned that if it is in between 0 and 1, then it has to be decay. So since 0.5 is in between 0 and 1, this function is going to be a decay function. Now our initial value, remember that's the number that's outside of the parentheses, so in this case it's just going to be the 12. And the growth or decay rate, that's just the number that's inside the parentheses, so in this case it's just 0.5. Okay, for 6B, is it growth or decay? Notice our growth or decay rate is going to be a 2. That is bigger than 1, so this one's going to be growth. The initial value is the one outside of the parentheses, so this one would be 100. And the growth or decay rate is what's inside the parentheses, so that would be a 2. Okay, last two, number 7. Denver's population is currently 124,900. The population doubles every 25 years. What is the population 100 years from now? So we need to write an equation here. So it's going to be y equals. The initial amount is going to be the number outside. So that would be 124,900. And then it says it doubles. So we know that doubles means 2. So a 2 is going to go inside the parentheses. It's going to be to the power of t. Now notice it says it doubles every 25 years. And we need to figure out what the population would be 100 years from now. So let's see how many times it would double in that 100 years. So we have 25 years, that's 1 time. 50 years, that's 2 times. 75 years, that's 3 times. And then 100, that is 4 times. So this is going to be doubling 4 times. Also, what you could do is you could take the bigger number, which is 100, divide it by the smaller number, which is 25, and that would also give you the 4. So that's what we're going to replace t with. So y will equal 124,900 times 2 to the power of 4. And we get 1,998,400. That's how many people would be in Denver after those 100 years. And last one, 7B. Markel deposited $610 into a savings account, earning 15% interest. To the nearest cent, how much interest would he earn in 5 years? Okay, so we know he's starting with $610. That's our initial amount. And he's earning interest, so this is going to be a growth problem, meaning we have 1 plus 15% as a decimal is 0.15. It's going to be to the power of t. So now we need it after 5 years, so this is going to become y equals 610 times 1.15 to the power of 5. Then I just have to put this into Desmos. Oops, not there. And it was after how many years? 5 years. So then he'd have $1,226.92. Okay, but notice this one is asking for the interest. So like we learned in class, that means you have to subtract the amount he started with, which would be minus $610. And then you can use the calculator. So you would get $616.92. That would be the amount of interest he has. And that is it for this review.